Hey guys, today's video is completely unsponsored, but is dedicated to the National Model Railroad Association. This video is a clinic I gave today, which is August 22nd, 2020, on Arduino hands-on. This is part deux, or part two. The first one is also on my YouTube page. If you enjoy the video, please take a moment to click the like button. If you want to see future content, please subscribe to my page and click the bell to be notified when a new video comes out. Thanks a lot. Richard asked me to continue on with the last one I did on the first bit of Arduino hands-on. I took it and I ran with it with some very simple sketches that kind of build on the first one. And it's my first presentation on it, so if I stumble a bit, I apologize. But just so you know, I have a large cup of coffee. I'm good, okay? We'll do a couple of 5-minute intervals in here where you'll be setting up your Arduino, etc. And if we need a little extra time at one of them, we can set another 5 minutes so people can go to the restroom, etc. Because we all know that the mind can only handle as much as the butt hurts. So, all right, let's move on. This is Arduino Hands-On Clinic Part Deux. Just for everyone's information, I'm recording this external to the call, and it will go up on a YouTube link. So if you want to review later on, you certainly may. It'll be a little more polished probably than what would be just recorded online. All right, first step. We're going to use today the Arduino Uno. The Uno is the second to the largest form factor of Arduinos. It has 14 digital outputs, 9 analog outputs, and that's actually incorrect. It's 9 analog outputs, 6 analog inputs. It just uses a standard USB-A, or in some cases a micro USB, to connect to the PC. The little jack that I'll show you in a minute accepts a 12-volt DC maximum, and it requires no special soldering skills. You can use breadboards for testing, which is why we're going to use this one today. This is the Arduino Uno. I've labeled the 2 inputs that are primary on it. On the left, the top one is the USB-A in this case. Bottom one's a 12-volt barrel plug. Across the top, you can sort of read the pins 0 through 13, and then on. And down below, you have analog 0 through 5, as well as 5 volts ground and several others. We can go over, I think if you look at my last clinic, we covered those pretty well. So next up, if this thing behaves, there we go. These are some ancillary devices that I had outlined on them. The sensor we're using today is not on here, but it's basically the same. So let's go through them. The first one is an infrared reflective sensor. If you can see my mouse, you have a transmitter, which is the clear one, and the black one is a receiver. So the IR bounces off things and comes back, and that's what activates it. The next one is a passive infrared sensor, which means it has no transmitter. It just detects heat as it gets near it. Maximum range is, in an average room, is about 2 meters. They advertise 3. I haven't made it work that far yet. The next one is probably part of the kit you got. It's called an ultrasonic sensor. This one requires some additional logic to do, and we will not be using this today. There's plenty of YouTube videos and sketches out there on how to use this, but this thing has actually got a pretty good range on it. It will send your cat into orbit though, so be fair warned. All right, down here on the bottom, we have a solid state relay. Let me give you a couple of caveats for this, guys. These require a pretty significant current draw on the order of about 150 milliamps, or the relay will not unlatch. So it's better for heavier applications. You have a 5-volt DC input, DC and ground, and a input here, which it toggles it on and off, and the output just acts like a little switch. The next one is my favorite one. This is a double pole, double throw, low level relay. This one has a double pole, double throw relay. In other words, just like a double pole, double throw switch. It runs off 5 volts and ground, and an input pin, which can come from the Arduino. The next one is 8 single pole double throw relays. The outputs are over here on the right, and each one, the board runs off 5 volts, which comes in down here, and each of these relays has a low level logic input, so you can turn them on separately. Next up is the buck, and they're called buck voltage regulators. I got to figure out how to get rid of that. There we go. Okay. The buck style voltage regulator it will take a DC input over here on the right of 5 to 30 volts, and it will actually drop down all the way to 3, believe it or not. And the output will put out 1.5 to about 28.5 volts at 3 amps. And the size of this thing is, I don't know if you remember seeing it in the last one, but they're about 1.25 inches long and a little over 1/2 inch wide. If you put a bridge rectifier on the input, you can actually use AC on it, and there's a little capacitor here that smooths it out and makes it quite usable. I have a YouTube video on this, just on this device, and ways to use it. So we'll cover that later. We will not cover the buck today. We're just going to talk about Arduino. And I'm fighting this again. There we go. There are other devices that popped up on the left there. There's MP3 players, push buttons, LEDs, resistors. There is actually, I don't remember if the kit has the joystick in it or not, but there's joysticks, all kinds of ancillary devices and boards for the Arduino. Literally, we could cover hours on just the boards that are available for it. All right, so here's the goals for today. First goal is introduction to the pin structures on the Arduino, analog and digital. We covered that last time, so I'll go through it quickly. Hookup and use of sensor inputs to drive outputs. Some new basic commands and command line structures. And use a switch to turn on a relay for lighting use. We're actually going to simulate the relay by turning on an LED. And then we're going to use a sensor to turn on a relay from, I've doubled that line, okay? I'll use a sensor or two to run the blink sketch and make it into a grade crossing flasher. All right, here's the sensor output types. There are, on any given sensor, there are multiple output types. There's analog outputs, and these can only be hooked up to A0 and A5 on the Arduino for analog input readings. Now, anybody who knows Arduino knows that if you're using a Nano or a Pro Mini, there are more than 6. We're just gonna keep this subject into the standard Uno. The output value on these, as it's read by the Arduino, is a value of 0 to 1024. So if you hook to the analog input and you actually look at it, you'll see as the sensor gets closer or anything, it will go from 0 to 1024. If it's hooked to a digital input, 0 to 512 is considered a low, and 513 to 1024 is considered a high. 400 to 600 is considered a gray or unbalanced area. And this becomes problematic because the Arduino can kind of choose whatever it wants in that area. And so unless you're looking for, you write code that looks specifically for a value of 513 or low, or you can actually set it to 700 if you want. But then, you know, it's not good to do a digital read because you're not 100% sure what you'll get between 400 and 600. So it's recommended that you only do an analog read if you're going to use those sensor inputs for reliability. In most cases, we just want to turn on and off things. So a digital read is better, and that's what we're going to talk about now. Sensors, their newest breeds of sensors come with a digital output, and I have one right here next to my coffee cup. And I'll get it to the camera, and I can't see my camera, guys, so just bear with me if it's out of focus. But you'll see there's a 5-volt, a ground, and a DO, as in dog 0. That's digital output. So if the sensor says DO, it's already been set up with the logic on the board to give you a nice solid digital output so that there are no gray areas and they work very reliably. Okay, it can be hooked up to any input from D2 to A5. As a reminder, don't use D0 and D1 unless you absolutely have to, because those are your serial input pins. You can use them, but the first time you try to upload a code with something hooked up to them, it will not work. So I just don't use them at all. The output out of the board is either a low or a high. That's what you get. And so when you do a digital read, which you'll see in the sketch, you can be relatively sure that it's going to work correctly. And this is easily defined in the read statements, which we'll go over as we get into the code. Okay? All right, hardware reminders. This is the breadboard. If you can see my mouse, the breadboard that's in your kit has a blue line and a red line, and it's split right down the middle. That split means the red does not continue on. All of the ones on the left and the right of it are all connected together horizontally on the blue and the red. And I use the blue as ground and the red as positive. That's kind of what the standard is for it. And the other pins, the 0 through 60, are in groups of 5, and you'll see split down the middle horizontally. So you can hook to these top 5 or to the bottom 5, and they're all hooked together. As we go through the connection, you'll kind of see what it looks like. Okay? This is the Arduino Uno, and this is the sensor I specified. It's the LM393. It's actually the board, the chip number, but it's called an LM393 sensor. And you have a DO here, a ground, and a VCC or 5 volts. This one is a photovoltaic sensor. Therefore, it's not infrared. I'll go through it at the end and tell you what you can do with this to use an upgraded sensor from the photovoltaic. Now, I will tell you, the logic on the LM393 behaves very well with the photovoltaics. I've got them in several installs, and they work great. But if you're like me and you prefer the digital type sensors, then it's quite simple to hook them up. All right, here is our first hookup. I used a program called Fritz, F-R-I-T-Z, to draw this. This will be what you're going to hook up. The one caveat I'll give you, if you can see my mouse pointer, is just keep in mind that I screwed up on the ground connection going up from the Arduino up here, and I went on the wrong side of the split. This one did not show a split on it. So take this ground that comes from the Arduino and just move it over to this side, say up around 39 or 40. Everything else should work just as it is. I'm going to go ahead and set a 5-minute timer, and we can unmute, okay? And you guys can take some time to hook it up, and we will be using the Sketch 0 for this. So go ahead and start the hookup, and we will do the timer, okay? You know, the one thing I thought of, go ahead and unmute, will you, Richard?
Go ahead, Larry.
Yeah, I'm going to do the one thing I forgot is the timer's going to be running here, and you guys will lose the picture. So I will just do a 5-minute timer here myself on my phone. Okay?
Okay, that works.
And go ahead and unmute everybody, Richard. Since I'm screen sharing, it's oh, there it is. Okay.
Got it.
We probably won't go 2 hours, so we'll have some time to talk, I think, in the end on this, guys, about the sensors and some of the things I've done with them.
Is it going to matter if your board doesn't have a split?
If it doesn't have a split, then you don't need to worry about it. And I started the 5 minutes from now. I'll give everybody an extra minute.
Okay. And if you get it hooked up, it's a good time to replenish your coffee cup and hit the head.
Larry, what does fritzing mean again?
Fritzing is the name of the program that you use to draw the this screen, but you can also put your code in it, and it's also a replacement for Arduino IDE. It allows you to put it in and upload to the Arduino, as well as the very expensive version. You can simulate everything. So like if you push the button with your mouse, the light would come on and stop that. Stop that.
Okay.
That's my
Larry,
mouse.
Okay, Larry, at some time, probably at the end, if you could put in where people can get the Fritz program, just put it in the chat, and people can see that on their own. And
Yeah, you can just do a Google search for Fritz, but I think it's fritz.com. It's a German company. It is a pay program, I'll warn you. It's I think $8, but that's unlimited number of installs. The expensive version is $35. But I'll put it in the chat, no problem at all. All right, so I'm going to jump out of this for a minute and get into the Arduino IDE, which I should have done earlier. We just had someone new join, Richard.
person should be in now.
All right, so I'm in the Arduino IDE program with the switch output sketch loaded. Is there anybody on here who does not know how to upload the sketch?
I don't.
Okay, Garth, the first thing you're going to do is, you see this, the first thing you need to do is go to Tools, and you come down to where it says Board, and you see where it says, mine says Arduino Nano. You need to change that to Arduino Uno, and it'll be under Arduino AVR. or it may just be listed as Arduino Uno. This is the newest version of Arduino, so they changed things a little bit. The next thing you're going to do, Garth, is come down, go over to Tools again, and go to the port, and tell me what you have there.
Oh, I was unable to get the disk to work to load this, so.
Okay. Unfortunately, Garth, I don't have time to troubleshoot that now. We should have known that earlier. My apologies. So you'll just have to follow on and do it next time. Okay?
Yep.
Question, I need to know where the red wire goes now.
Okay, hold on. I'll go back.
No problem.
I will go back. The red wire comes from 5 volts down here at the bottom, goes up to the 5-volt bus.
Okay.
And then 5-volt bus to the positive lead of the LED.
Thank you.
You're welcome. Anyone else? Okay. So let's go through the sketch really fast. Not too fast, but fast enough. Okay. So if you look up at the top here, you've got /star, and down about 6 lines is //. That indicates that's a comment. Okay. And so those are just the comments that I wrote this sketch. The first thing we have down below that is int, which is integer, input equals 2. So what I did is I said the name input goes to pin 2. Integer, the name output 1 equals 7, means that output, wherever you see output 1, just think 7. All right, next step down is called the setup function. This is the same on every sketch. Setup runs once when you power up the board or if you hit the reset button. And it's identified by void right here, which indicates void is program, if you will. Okay? And so the first thing I did is I entered, well, okay, I got to change that, but that's all right. So I initialized the pin 7 as an output. So I did pin mode, output 1, which equals 7, output. And notice it's all in caps in blue. That means it's a high level output. Now I did pin mode, input is input pull up. Okay, so input pull up is kind of a unique thing to Arduino. You can identify it as an input, but then you will have to put a resistor between that pin and 5 volts. If you use input pull up, logically it puts a resistor in. So it saves you putting in a little piece of hardware. Okay, the next thing I did is I did a digital write output 1 high, and that turns on the LED. I did a delay of 1000, which is 1 second. And then I did a digital write of output 1 low. It turns off the LED. And then I did another 1 second delay, so that when you plug this in and upload the sketch, the first thing you'll see when it's done is the LED will come on for a second and it'll go out. All right, so the loop section is the main program. This just runs over and over and over again, okay? So when it's finished, it goes back and runs over again. So I did void loop. And if you see this open bracket to the right of loop there, that means wherever the closed bracket is for that, everything inside of there happens in sequence. So each time you have an open bracket, everything inside of that happens as, you know, until it's done, and then it'll go on to the next. So we did a simple if statement. It says if we digital read the input and it is equal to low, and then we did an open bracket, then it will digital write output 1 low. And I'll explain why in a minute. when we put a low on that pin, it turns on the LED because the LED's positive side is hooked to the 5 volts. And then we do a 3-second delay and it loops over again, okay? So as long as you hold that button down, the LED will come on and it'll stay on forever. And you let go of the button, roughly 3 seconds later, the LED will go out. So below that, we close that bracket. So that means that sequence is done. And we have an else command. So it says if digital read input is low, and so when you let go of the button, it's not, then it will digital write the output one to a high, which turns the LED off. Pretty simple when you look at it in the big scheme. Okay? So to upload the sketch, first thing you got to do is compile it and upload. You need to make sure you have, as I said earlier, your port set to the right COM port and the board set to the right style. And then you can click on this arrow up here to the upper left. That you can click on this and it will upload the sketch. I do not have an Arduino hooked up, so I don't have to upload the sketch. So go ahead and do that. And you should see, if everything works correctly, you'll see it compiling the sketch down on the, let me go back over there. If I'm going to simulate it, if you click here, down here at the bottom, it'll say compiling sketch. When it's done with that, it'll say uploading sketch.
Hey, Larry, sorry about that, but we lost internet for about a couple minutes there. So,
No worries. No worries at all.
Anyway, so I'm just trying to catch up right now, so I may just sit and watch as you go along and then get back with you on some of this stuff.
No worries. So this should be pretty much your hookup, and you should be able to press on the button and make the LED come on. Air conditioning's running, so it's like dehumidified to the maximum in here today. So this LED output on pin 7 here, that we're going up to the resistor, if you had one of those relay boards, you could hook the relay board VCC to the 5-volt bus and the ground to the ground bus. And then that wire going from pin 7 can go to the input of the relay board. And instead of turning on the LED, it would turn the relay on and off. You can actually have it do both if you want to. And so you can actually I've safely run 3 relays off of 1 Arduino output. But if you wanted to, you could simply modify this sketch and you could create another output, and you'll see in a minute we do on the next sketch. And you could do like 3 outputs and then just change these digital writes to an output 2, output 3, you know, copy and paste it in, and they would all turn on and off at the same time. Has anybody made it work yet? Silence is bad.
Yes, I have.
Okay. Pretty sure you would, Al.
Yeah, well, I had to do a few minor little things. One thing you might want to remind everybody of is that if it doesn't work, try reversing the leads on the LED.
Yeah, and thank you for the reminder. The long lead on the LED is the positive. I covered that in my last clinic, and I always forget to mention it. So if you pick the LED up, and you look at it, the longest of the 2 leads is the positive lead. All right, I'm going to minimize this again so I can get back into my presentation. Okay, as long as this thing will let me.
I have a question.
Uh-huh.
Before I uploaded the sketch, my LED was on, and then after I uploaded the sketch, it doesn't do anything anymore. The LED is off. It does not come on when I press the little switch.
Okay.
Unless I've got one of the wires, and it was on whenever I got it all hooked up and hooked the power to the board. The LED
Yeah,
was
and that's
on.
very common. The outputs of the Arduino are a high until you tell them otherwise. You just verify you got everything hooked up right. It should be out until you push the button.
Well, when I push it, it still doesn't do anything.
Okay, you verified your connections are right.
Let's see.
Wouldn't worry about the LED connections. Those apparently are probably, well, I would verify that the blue wire is on pin 7.
Yes.
And that
It
the
is on pin
switch
7.
wire is on pin 2.
The yellow one?
Yes.
Yes, it's on 2.
All right, so can you see my screen?
Yeah,
See this ground wire coming from ground up to the bus?
right.
Take it and you can unplug pin 2 and plug it into pin 2. Unplug the yellow wire and take that
Okay.
ground wire and just hook it to 2 and see if the light comes on.
Pull it out of the breadboard and hook it to 2.
Yes, pull the ground wire out of the breadboard and plug it into where the yellow wire is now. You can unplug it.
Yep. The LED comes on.
Okay, then you don't have the switch wires correct or something. Okay.
Okay.
Try
I'll have to go
rotating your,
ahead.
excuse me, try rotating your switch 90 degrees.
Okay, I'll try that. I think I might have had it in this one slot over. Okay.
So, well, but that's a quick test, guys. You know, basically all we're doing with switches, we're putting a ground on pin 2. So it's not a bad thing that this happened. It kind of shows you that you don't even really need the switch if you don't want it, you know. Switch gives you your tactile input. Now, even with the sensor later, we'll go through the process here on it. Well, 10:49 and 55. Has anybody gotten this hooked up? Do you have any questions? The only thing we did is we added an LED, a resistor, and we hooked the resistor input to pin 8. So now we have 2 LEDs. And the sketch you're going to load on this one is O2 switch blink. All right, let's jump over to the Arduino IDE, and I will kind of go through this sketch a little bit with you. The only thing I did to this is I did an integer for output 2 equals 8, so that's pin 8. And in the setup, I defined it pin mode output 2 as an output, and I turned on output 2 and turned off output 2 in the setup. So both LEDs should come on and go off. All right, so now when you get down to the loop function, as complicated as this seems, it's actually not that difficult. Hold on a minute, guys, the printer's running. Welcome to a Zoom meeting, right? All right, so we will cover just one little section of it. We did part of this in the last clinic where we made the LEDs flash back and forth, but we let it do it continuously. So I did the same if statement. If digital read, the input is low, I told it write output 1 high, output 2 low. Then I told it wait a half a second, and I told it write output 1 low and output 2 high. So we did that over and over and over again. All right, so each one of these evolutions that I'm highlighting right here will take exactly 1 second, okay? So if you go to it, you'll see that there's 5 seconds of these evolutions on there. So when you upload the sketch, the first thing you should see is both LEDs should come on for just about 1 second and then go off. At that point, if you push the button, the LEDs should toggle back and forth between on and off. Want to give it a try? Anybody have it working? Any questions?
Yeah, mine's working. Thanks, Terry.
Go ahead.
Yeah, mine's working.
Okay. So basically, this sketch just proves that the flasher works. And now what you'll realize is when you let your finger off that switch for 5 seconds, it keeps flashing. Everybody agree? Okay, so we're going to use that with a sensor now. We're going to modify this just very slightly on our next sketch. We're going to be done in about another 15 minutes. I actually expected more problems. So I will go through here and why is this thing aggravating me? So here is the next one. You have the sensor. If you have the sensor, this is how you're going to hook it up. So go ahead and you're going to remove the switch. The only thing you're going to do is the ground is going to go to the ground of the sensor, and the 5 volts is going to go to the 5 volt input of the sensor, and pin 2 ultimately is going to end up on that D output of the sensor. So go ahead and do that. I'll give you guys a few minutes to do it. This one shouldn't take as long because you're really just moving a couple of wires, but I'll give you 3-4 minutes. You can substitute any of the sensors that have an output. Even the analog ones, the reflective ones, if that's what you got, you can hook it up to this. It doesn't really matter as long as it's got an output. In this case, just remember on those analog reflective ones, you've got to have a pretty defined reflection. One of the problems, and I covered this in my YouTube video on them, on those sensors, is they don't reflect off of matte black hardly at all. So you've got to have them pretty close to the actual device that it's going to reflect off if it's got a flat finish at all. And guess what? 80% of our steam engines are flat finish black, maybe higher, but I would say 80% at least. So that's where the problem comes in with them.
Larry, will you put out an email or something with where the YouTube site is where we can go back through this at a later time?
Yeah, absolutely.
After
Once
this.
I get the video all fixed up, which will probably be tomorrow, I have the email addresses that Richard had here. As long as Richard doesn't mind, I'll ship it to the group. Or Richard, you can just ship it to the group if you want to.
Given my lifestyle right now, why don't you go ahead and do it, Larry? They'll get it faster.
Okay, no worries, buddy. Gotcha. And you can look through all of my YouTube videos. I'm not one of those guys that's making money off YouTube, so don't think I am. That's not why I'm promoting it. I'm promoting it because I want you to have the abilities to do the things that I do.
Hey, Larry, if you have a link, can you drop it in the chat?
Yeah, the search phrase you can do on YouTube is Lawrence Eggering or Creaky Chair Models, either one. And I cover that at the last screen here. So.
Okay.
So you can get a piece of paper and write it down later if you want.
Oh, I'm just gonna cut it, paste it, and save it. Subscribe to it. So.
Okay. Yeah, I think I have like 50 or 60 videos up there. I got a bunch. No, a lot of them are just trains running around in circles from those yutzes over at the FCMRS, but you know. All right, so we're at 4 minutes. Anyone have one hooked up? I know, I tried to give you enough time to order some sensors. If you don't have them, again, you can simulate this just by the push button. This is to show you how to hook it up if you want to do it. Let me jump over to the sketch. Did we upload the sketch yet? Did we yeah, I'll learn to talk. Did we cover the sketch yet? I don't think we did. All right, so let's go to, let me open it. I was trying to be nice and keep that screen up for you guys. Okay, so this sketch is essentially the same. Sketch is the last one. There's one big difference. I'm going to highlight it right here. You see this digital read statement? It says the input is high. That sensor, let me start my video. All right, so this little sensor that I had here, the output on this is high. It's not a low. And this one is actually a low. This is the reflective. My apologies, I grabbed the wrong one. The other one I showed you, which I've now lost in this mess here, the output is a high. Oh, here it is. It was sitting on the Arduino. So now this is the same. At any rate, the photovoltaic sensor, the output on it, the digital output is inverse of what it is on these reflectives. So if you're using the reflective sensor, what you would see is until a train comes on, it's flashing. Until you cover it, it's flashing. You would just change that high to a low and everything else will work the same. So assuming, yeah, we just had somebody join on a cell phone. What's your name?
Ken.
Oh, did you drop off, Ken?
I was not. I had no sound.
Oh, okay. All right.
We can hear you from both.
Thank
You're
you.
echoing.
Yeah, I muted his video one, so. I should have recognized the number, Ken. Sorry. Anyway, you would, if it's working reverse of what you want based on the sensor you have, you just change that low to a high or the high to a low. Okay? Very simple. So if you've hooked up the sensor, now you should be able to cover that sensor because it, assuming you're not in a dark room, You cover the sensor, the lights should start flashing, and they'll stay flashing until you uncover the sensor and wait the 5 seconds for it to time out. I did not add a second sensor in here, you know, for both sides of a grade crossing. The reason is there is so many grade crossing circuits out there that you can just type in Google Arduino space grade crossing and you'll find a bunch of them. And this is just a basic one. So if you got a train going in a circle or, you know, they pretty much run in one direction, this will work every time. I would highly recommend, and we'll go over this in a second. Here we are. Come on. Okay, so this is the last section we have right here. This is, if you need help or you got questions and you decide 3 months from now you want to play with this and kind of make it work, and you run into it. It took me a while to get my brain into programming mode after a hiatus of about 15 years, call it 20. And I didn't have very many people to talk to. Since then, I found some really good friends, and I'll go over them in a minute. But my email is creakychairmodels@gmail.com or lawrence.eggering@gmail.com, either one of those. My website is creakychairmodels.com. So if you need my phone number, my emails, any of that, it's all on the website. Easiest way to find it, okay? The YouTube is listed as Creaky Chair Models or Lawrence Eggering.
And Larry, on the YouTube,
Yes.
just so everybody understands, these are 3 distinct words under Creaky Chair Models.
Correct.
Space in between them.
Right.
Okay.
I put the link in the chat for the YouTube site.
Oh, you're very good. Thank you very much. It's kind of like juggling with an elephant right here. So, you know.
Yeah, tell me about it.
Yeah, I used to do these all the time. I don't miss them all that much.
Yeah.
All right, so the next thing is this is some web and YouTube resources. Tom Kovichak runs Tom's Trains and Things. He has a lot of free videos on Arduino out there.
He does.
They're pretty good. Another guy that's really interesting, and he hasn't done much since COVID, is the DroneBot Workshop. This guy's got probably the nicest workshop I've ever seen for electronics, and he's really sharp. Now the next guy up is IOTT, Internet of Toy Trains. This guy was a developer of LocoNet. So when I say it's for experts, he talks over my head some days. And I have to go back and say, what was he saying? And then you got to get into that engineering mode, which I don't know about you, but seldom do I want to go there. He's developing an entire new home-built command station that will make DCC++ look like a rank amateur attempt. It'll make anything out there look like a rank amateur attempt, but trying to follow his logic. DIY and Digital Railroad is another good one. This guy has done some pretty good stuff. He's got an excellent grade crossing circuit if you want to use it. Bobots, and I think he called it. I have a sister-in-law whose nickname is Bobot. I think he calls it Bobots. Trains and Maker Zone. He's pretty sharp. And I don't know if you guys know about Model Railroad hobbyists blogs, but Jeff Bunza is, Jeff has become a really, really good friend over the years. He has a PhD in electronics theory from MIT, so he's a pretty sharp guy. But he writes excellent code, and he's the one that really pushed me back into Arduino. And his grade crossing is, if you look at my videos, you'll see the last grade crossing I did, I refined his initial code. And I tried to mark it up. If you need a copy of that code, just drop me an email and I'll send it to you. It's no problem. And I think I've marked it up well enough that you can figure out how to do it. But you'll see on my video, it actually runs servos, which take NJ International arms and drop them down and does flashing lights. It runs a 5-second bell sound when the arms come down and 5 seconds when they come up. So Jeff's been a real inspiration, and he's got some of the coolest animation stuff you've ever seen. He has a caboose that has a micro motor on a wheel set and a DCC decoder in it. So the caboose can actually be used as helper service, or in his video, he shows it going back down on a siding, and rather than just coasting, and when he disconnects it, he drives the caboose down a hill onto a siding, just as the prototype does. So this is the kind of stuff that's out there. I mean, the amount of things that you can do with this little device is unbelievable. And when you get down to the Micro Mini, that's the size of a postage stamp, and you realize it has the same number of inputs and 3 more outputs than this Arduino Uno, you can fit them in some pretty tight areas. So I think that's the end of my presentation, guys. Anyone want to talk about anything? Any questions?
I do have one little comment, Larry, that might help some of the people with these breadboardings. You can get I purchased some programmed prototype shields that you can plug in right on top of your Uno with all the grounds and all the power. It's smaller, it's the same size, and it's a little bit easier to go and put for small circuits. Putting them together for jumpers.
Yeah, the reason yes, you're exactly right. And they actually have the little breadboard right in the center of some of them.
Yes.
So the reason I didn't do that is, in the previous ones, we did this. So I wanted to kind of stick with it. But yes, that is a very good idea. And they're not very expensive either. I would say, what, $10-ish?
I think for $10, I think you can get 2 or 3 of them.
Yeah.
If you're going on someplace like eBay.
Yeah, if you get them from China, they're cheaper. But if you do Amazon, yeah, it's around that. I'll leave this up for a minute so you guys can jot notes down of this. We were a little short, but hey, it's all right. It gives Ken and Richard more time to talk, right?
Yeah, nothing like having the opportunity to talk more. Larry, if you could, or even Al, a couple of sites or sources for the sensing devices and what people should look for when ordering from a catalog or online, some recommendations.
Yeah, I can unshare my screen and go put some in the chat. Okay.
Okay.
Would you guys prefer eBay or Amazon? Because I can do both.
Just put both of them in there.
All right. Well, the photovoltaic, you already have the Amazon search for that. So.
Yeah, I got 10 of those.
Hey, Larry, I may have missed it. When you have the flat black on the photo sensor, how do you solve that?
There is none. That's the problem. You have to keep it very close to the engine if you're going to do it, like within an inch.
So if you had your smoke box silver and aimed it there, would that be different?
Oh, it worked fine. It worked fine. Or if, a lot of the engines come in not an exact flat, but, kind of a semi-gloss, that'll usually work okay also.
Okay.
Can you aim it at the wheel sets?
Pardon?
Couldn't you aim it at the wheel sets?
You can.
The wheel
You
sets
can.
typically have are brighter usually, even on diesels and steam.
So if you have the rods, you could, your rods are generally silverish or metallic.
And
Right.
usually the wheels are gloss rather than flat.
The thing is, once you dull coat it, what happens is it doesn't really reflect, it disperses. So you get a weaker return on it. The photovoltaic one, oh, and I should cover that. The photovoltaic one that I put in there, you can put between the tracks, and it's small. It's under 3 millimeters. Okay. You can, if you look at the board when you get it, where that sensor is a plus and a minus stamped on the board. You can literally get one of the, and I'll put a link to those sensors in also. You can take 2 wires off that plus and minus and put them onto a 3 millimeter digital sensor, and you can run that thing 30 feet and put the board wherever you want it. Or you can mount the board right under where you are if you want. I got an Arduino sensor video that I show you how to remote them. I don't remember if that sensor's on there, but it's the same premise.
When you do your wheel squeal detectors, is that between the rails or is that a side detector?
The ones that I've installed, I have 2 that are in between the rails, and I have 1 that's a reflective, so I can do it either way.
Okay. Just got to get the infection rate down a few more points, and we'll do it.
It's sitting here waiting on you. Isn't it funny how that works?
Yeah.
Okay, other questions for Larry? Comments?
I thought this was really helpful. I've gone to Arduino clinics before, and it was just good to get me back up to speed a little bit, Larry. Thank you.
Oh, thank you. Thank you very much. I mean, that's my goal, is to help you guys. What I'll do is I will email, I think, how did I do it with you, Richard? Because of the timers, I think it adds a lot of size to the file. So if I take the timers out, guys, I think I can email you the entire presentation.
Yeah,
So.
I think, yeah, taking the timers out, it becomes very easy to use. So
I'm worried more about the size than anything. So I'll if not, I will send a link out where you can download it. Okay, so I put a link for the eBay sensors, the IR reflective sensors from eBay and Amazon. And you'll see there's not a whole bunch of difference in price. If you're an Amazon guy, they're about $1 a piece. They're very inexpensive. As well as you previously should have the links from for the photovoltaics. The photovoltaics have become my new favorite. They're the easiest to hide, and as long as you have almost any light at all, they work pretty well. They've really fixed the problems that used to exist with photovoltaic sensors, and you got to have all this light. That new chip really works well with it. So.